Hello and welcome to a video on factoring trinomials that have a leading coefficient. So by a leading coefficient, we can look at a few examples here, and we can see that we're talking about that first term having a coefficient other than 1. So this time it has a 3. And notice if you look at the three terms, there's no common factor. There's no way to factor out anything first. So we're kind of stuck with that in our first step. And then if you look at the second one, also leading coefficient here of -3. Here we have a leading coefficient of 27. That might be reducible a little bit because we can take a 3 out of that, but we're still going to end up with something other than 1 there. And after we do a couple of examples just factoring, we're going to look at how we use the same process to solve equations by factoring. So here's an equation which we're actually going to solve and get the two solutions by factoring. Okay, so first let's take a look at this first example. And we're going to do this first by splitting the middle. And we're going to split the middle term and see how we can do this by grouping first. And then the second example, we'll do it by the box method. So we're going to see two different methods in this video. All right, so first, again, we're stuck with that. So all we can do is really try to break this up. So we're going to try to break up this middle term into two pieces. And we do that by making an x first. So here's how the x works. You're going to carry down the middle term here for the bottom of the x, so that's the -4x. And then in the top of the x, you're going to get the product of these two terms right here. So the product of these two terms is -45x squared. All right, now that we have these two pieces, we're going to look for something that has a sum of -4x and a product of -45x squared. We're going to do that by looking at the possible products of 45. So when you go through the possible products of 45, eventually you come to 5 times 9, or 9 times 5. So we have 5x times 9x, and I chose that because the difference between these two is 4x. And so I can kind of pay attention to the details of the positives and negatives to get this to be a product of -45 by making the larger number here negative and the smaller number positive. Now the product is -45x squared, and the sum of these two is my -4x. So that just means I'm now going to do for my next step is I'm going to split that middle term into these two pieces that of course add up to -4x. So I have 3x squared plus 5x minus 9x minus 15. Okay, and we can put this in either order, by the way. It doesn't matter if we put the 5x first and the minus 9x, except I made it a little bit harder on myself because by putting the 9x second, I have a negative sign there. And so when I have a negative sign there, I like to change that to plus a negative number. So I'm just going to rewrite a quick step here. So 3x squared plus 5x plus -9x minus 15. It's the same thing, just separated by a plus sign. I'm going to take out the GCF from each group, so I'm factoring by grouping as my next step. In the first group, I have a common factor of x. So I pull an x out in front, and I take a 3x plus 5 left over. From the second group, I have a common factor of -3. So I'm going to pull out that -3 in front, so plus -3 times, and I have 3x plus 5. Notice they're both 3x plus 5. So I have 3x plus 5 as my GCF times x plus -3, or x minus 3, and that's it, fully factored. Okay, let's look at a similar problem. We're still going to split the middle, but now we're going to do this using what's called the box method. So first, let me set up the box method and kind of show you how that starts, because it makes it a little easier if you remember this. So I'm going to first notice that there's no GCF here. So I always look for that first, but there isn't one. So I'm going to make a little 2x2 box. Okay, there's 4 spaces there. And in the top left, I'm going to put that first term. I'm actually going to do this after I factor out a -1, because it does make things a little bit easier. So -1 times 3n squared plus 10n minus 48. Okay, I always prefer to factor with a positive first term no matter what method I'm using. So I have 3n squared in the top left and negative 48 in the bottom right. Okay, now how do I get these? I get them by splitting the middle. So I'm going to do the same thing that I did in the last example. I'm going to make that little x and carry down the 10n for the middle, and on the for the bottom, and on the top I put the product here, which is 3 times 48, which is 144. This is negative 144n squared. And I break it up in a way that I need a product of 144 and a sum of 10. And it takes a little bit of searching for this one, because the first thing that comes to mind here would be 12 times 12, and then the next thing probably is 2 times 72, but neither one of those work. But with a little bit of searching, you'll find out that 18 times 8 is also equal to 144. So an 18 minus 8 is 10. So if I put an 18n and an 8n, and I want to have a positive this time, so I'm going to make this one the positive because that's the bigger number, this one the negative. Now if I multiply them together, I get the negative. If I add them together, I get the positive. These are the pieces of the other two corners of the box. So I'm going to put the 18n in one corner and the negative 8n in the other corner. Now I go ahead with this box, and I'm just going to take all of the GCFs in both directions here. So I'm going to look in this direction first, and I'm going to pull out a n, just an n. That's the only common factor there. I'm going to pull out a common factor here of, let's see, between 18 and 48, all I've got is a 6. So I'm going to pull out a 6 from there. And then going this way, I'm going to pull out 3n. It's my only common factor. And going this way, I'm going to pull out a negative 8. And there's my two factors, n plus 6. This was a positive, so it's going to be n plus 6 times 3n minus 8. The negative 1 is still there, and there's factored form of that polynomial. All right, let's look at one more that we're going to use the same method for. So let's look at here, and this time we're going to factor, but this time there's more than just a negative 1 that we can take out. We can take out a negative 3. So again, I'm taking out a negative 3 because I like that first term to be positive whenever I factor. So if I take out a negative 3, negative 3 times 9x squared will give me negative 27x squared. Negative 3 times 12x will give me a negative, if I multiply this, I get negative 36x. And negative 3 times 32, it's going to have to be subtracting 32 to give me negative times a negative to give me a positive 96. Now that's all I can take out. Now I'm stuck with factoring with a leading coefficient, and this one's a little bit messier because these numbers are even bigger. The bigger the numbers, the harder it can be to use a guess and check method. But in this case, we're not going to use guess and check. We're going to use the same method with that box. So now that I've got this part factored, I'm going to start my box. And in the top left, I'm going to put the 9x squared. In the bottom right, I'm going to put the minus 32 or negative 32. And then I'm going to see what happens, how we're going to split the middle. So I'm going to put, make the x here. And in the bottom of the x goes the 12x. And in the top goes the product of 19 times 32. And 19 times negative 32, or sorry, 9 times negative 32 is negative 288. So this is negative 288x squared. So now I'm looking for a product of negative 288x squared and a sum of 12x. And again, after a little bit of searching, I come up with 24 times 12. So 24x, well, 12x times 24x. This has to be positive, so this needs to be the bigger of the two numbers. So I'll make that one the positive, that one the negative. And those are the pieces that go into my other corners. So it doesn't really matter which way I put these. I'm going to put the negative 12x here and the 24x here. And now I go ahead and I take out the GCF. So going in this direction, looks like I have a common factor of 3x. Going here, I'm going to take out the negative, and it looks like it's going to be a negative 4. Going this way, I'm going to take out a 3x. And going this way, I'm going to take out an 8. So I have 3x minus 4 times 3x plus 8. And that negative 3 is still part of this, so I'm going to put that out in front. And there it is. All right, let's look at another example. So in this problem, I can see I can take out a GCF here, and it looks like 8 comes out of all 3 terms. So I'm going to take the 8 out in front before I do anything else. 6x squared plus x minus 5. This time it's an equation equal to 0. So I'm going to go ahead and split. I still need to split the middle, even though it's only 1, because I've got a leading coefficient. So I'm going to go ahead and make that x factor first. Okay, so when I made the x factor here, I came up with 6 times negative 5. 6x times negative 5x has this product and this sum. So I'm going to put these values in the corners of the function. So I have 6x and negative 5x. Pull out the greatest common factor. Going this way will be an x. Going this way will be nothing, so just a 1. Going this way, I can take out a 6x. And going this way, I can take out a negative 5. And so there we have 6x minus 5, x plus 1. Still carry that 8, so I have 8 times x plus 1 times 6x minus 5. Okay? Let's do the last one by grouping again, just kind of to mix it up a little bit. So let's solve this equation by grouping. Let's first set everything equal to 0. So I'm going to subtract the 3n squared from both sides, and I'm going to add the 8n to both sides. So I get 12n squared plus 30n. When I add 22 plus 8, that's a 30n. And then minus 72. Then I notice I have a GCF that I can take out of 6. So I'm going to pull out a 6. I have 6 times 2n squared plus 5n minus 12. Then I'm going to split the middle here, so I'm going to make my x. And that's going to be product of negative 24 n squared and a sum of 5n, and we come up with 8n and 3n. Again, this is positive, so this is going to be a bigger one will be positive, and this will be negative. So there's the 2 pieces that I'm going to split up to give me my 5n, and now I have all 4 pieces. Sorry, all 4 pieces for the box. So I have 2n squared, negative 12, 8n, and negative 3n. Factor out the n going this way. Factor out a 4 going this way. Factor out a 2n going this way. And let's take a negative 3 going this way. And there it is. It's going to be, we still have 6 times n times 2n minus 3, and this equals 0. And I didn't finish the last one. I realized I forgot to solve it, so I factored it, but that equals 0. So in both of these, in solving, we set all the factors equal to 0, only the ones with the x's. So x plus 1 equals 0, 6x minus 5 equals 0. Here we would go n plus 4 equals 0, and 2n minus 3 equals 0. And so we would get our 4 solutions. Or 2 for each one. So x equals negative 1, x equals 5 over 6, n equals negative 4, and n equals 3 over 2. Okay, I hope you found this helpful.